Hello, dear students. Welcome. I am Dr. Poornima A S and I am going to teach you about probability distributions in this video. Distributions. Frequency distribution. There are two types of distribution. Frequency distribution. It is a listing of observed bar actual frequencies of all the outcomes of an experiment that actually occurred when experiment was done. For example, in your class, if I want to classify students according to your undergraduate degree, I will say there are engineering students, there are about 15 of them. Art students, BA, there are about 20 of them. Science students, there are about 5 of them. Like that, when I make a list of observations, it becomes frequency distribution. Similarly, in probability distribution, it is the listing of all possible outcomes that could occur if the experiment was done. It can be described as a diagram, a table, or a mathematical formula. There are probability distribution, again, is of two types. One is the discrete probability distribution, another is the continuous probability distribution. Discrete probability distribution is is for discrete variables, whereas continuous probability distribution is for continuous variables. Accordingly, the metrics we use, it is called discrete metrics and discrete probability distribution and Poisson distribution are used for discrete variables, whereas normal distribution is used for continuous variables. Now, what do we say discrete? What are discrete variables? Discrete variables are variables which vary in whole numbers. For example, number of chocolates sold, number of glasses of lemonade sold, number of ice cream packets sold, etc. Whereas in continuous PD, the variables can take decimal values. For example, height of students, weight of students, and liters of milk sold, liters of juices sold, weight in kilo of ice cream sold. So when that is for continuous, uh, when the variables are continuous, we have to use continuous probability distribution. And the most used probability distribution for continuous variables is normal distribution. Now we used discrete metrics and continuous metrics is the same. Discrete metrics means those metrics which doesn't vary in decimals, whereas continuous metrics are those metrics which vary in decimals. Okay, so with this, we will go ahead and learn about probability distribution, that is discrete, again continuous, which we have already explained. So again, I just highlight random variables takes only limited number of values, number of heads in two tosses, can take any value like height of students and weight of students in the class. Tree diagram. What is this? Let us take an example. A fair coin is tossed twice. In the first trial, there are two possible outcomes, that is head or tail. In the second trial, there are two possibilities, that is head or tail. After getting tail, there are two possibilities, either head or tail. After getting head, again when the coin is tossed, you can get either head or tail, or after getting tail, you can get head or tail. Now, these are the possible outcomes, that is head in the first trial and head in the second trial, that is called as HH. Head in the first trial and tail in the second trial is HT. Tail in the first trial and H in the second trial is TH. Tail in the first trial and tail in the second trial is TT. So there are set of 4 possible set of 4 possible outcomes, that is HH, HT, TH, and TT. Now, when we assign probabilities to each of these events, we get probability distribution. So how do we do that? I'm just coming, okay. So in the first trial, probability of getting head is half, probability of getting tail is also half. After getting head in the first trial, probability of getting head in the second trial remains half. It doesn't change. And probability of getting tail is also half. Therefore, probability of getting head and head in the first trial and head in the second trial, denoted by HH, probability of HH is half, half, half into half, that is equivalent to 1 by 4. Now, probability of getting head in the first trial and tail in the second trial is also equivalent to this half, half into half, that is equivalent to half into half, that is equal to 1 by 4. Probability that you have got tail in the first trial and head in the second trial is half into half, that is equivalent to half into half, 1 by 4. Probability of getting tail in the first trial and tail in the second trial is again half into half, that is equivalent to 1 by 4. So this is because the coin toss experiment is set of independent trials. First spin has no effect on the probability of the second spin. Now, when we list this possible outcomes, probability of 2 heads, this is probability of 1 head, this is also probability of 1 head, and probability of 0 heads. We have P of 0 heads is equal to 1 by 4. P of 1 head is equal to half. P of 2 heads is equal to again 1 by 4. How is this? P of 2 heads is this. P of 1 head is this plus this, that is equivalent to P of 1 head is equal to half, and P of 0 head is all tails, that is half into half, that is equal to 1 by 4. The sum of these possibilities, 1 by 4 plus half plus 1 by 4 is equal to 1. Okay, so this is it, H and H. It is 1 half, half, 1 half, 1 by 4, 1 by 4, 1 by 4, that is equivalent to probably is 1 by, total is 1. Probability of at least 1 is 1. This has got 1 head, correct. This has got 1 head, correct. This has got 1 head, correct. This has got no heads. So add these 3 possibilities, 1 by 4 plus 1 by 4 plus 1 by 4, that is equivalent to 3 by 4. This is how we calculate the probabilities. Now again, discrete probability distribution example table. Here we are tossing the coin thrice. We are tossing the coin thrice. That is, then we have in this outcome, it is head in the first trial, head in the second trial, and head in the third trial. The possible outcomes are listed in this. This is called sample space. So there are 8 sample points in this sample space. Total is 8. All the possibilities are considered, that is H, H, H. Head in the first trial, head in the second trial, head in the third trial. head in the first trial, head in the second trial, T in the third trial. Similarly, we have taken all the possibilities so that there are 8 possibilities. So then if let X represents the number of heads, X is equal to 0 head, means this only possibility is TTT, that is that 1 by, there is only one possibilities of the 8 possibilities, that is equivalent to 1 by 8. P of one head means what are the various possibilities? One head means there is only one THT, yeah, and TTH. There are 2 possibilities, 3 possibilities again. What are, yeah, P of one head, THH, yeah, here. There are exactly one head it is. So it is 1 by 8 plus 1 by 8 plus 1 by 8. That is total of 3, frequency is 3 and therefore it is 3 by 8. Now, what are probability of 2 heads? 2 heads means HHT, HTH, THH. Again, there are 3 heads, that is equivalent to probability 8 possibilities. Therefore, it is 3 by 8. Number of favorable outcomes divided by total number of outcomes. Now, the next possibility is probability having 3 heads, that is HHH alone. So here it is HHH alone, it is 3 heads. That is, there is only one possibility and it is equivalent to 1 by 8. So this is about how we use discrete probability distribution. Okay, that's all, dear friends. In this video, we have discussed the that the probability distributions are 2. That is for discrete and continuous. Discrete variables are those variables which vary in whole numbers, whereas continuous variables are those variables which vary in decimals. Accordingly, the probability distributions are 2. Discrete probability distribution and continuous probability distribution. Again, we took an example of how to formulate a probability distribution. That's all in this video, friends. Next video will be on binomial distribution. Stay tuned. Happy learning.